In this video, we are going to talk about conservative and non-conservative forces and how they are related to potential energy. Conservative force is a force for which the work done on an object is independent of the path followed. That means for a closed path, the work done will be equals to 0. For example, gravitational force. Consider a ball that is being tossed up. Here, the kinetic energy is transformed into gravitational potential energy, and at this point, the ball has the potential to transform this energy back into kinetic energy, and it does so as it falls back down. A non-conservative force is a force for which the work done is path dependent. That means work done will not be equals to 0 around closed path. For example, frictional force. You cannot recover the kinetic energy lost to friction as a box slides to a halt. There is no potential that can be transformed back into kinetic energy. The idea of potential energy is associated with conservative forces. Therefore, we define the change in potential energy as negative of the work done by conservative forces. Let us take an example. A box of mass m having weight mg is lifted from height h1 to h2. In that case, the work done by gravity will be equals to force into displacement. Force being the weight of the object, displacement h2 minus h1, and the angle between displacement and the force here is 180 degree. Simplifying this, we get work done by gravity is minus mg h2 minus h1. Therefore, the change in potential energy will be negative of negative, that will be plus mg h2 minus h1, or the change in potential energy is mg delta h, which means that the work done by the conservative force is stored in the form of gravitational potential energy. The same can be applied to another conservative force, the spring force. We have previously derived the expression for work done by elastic force, which is equals to half k x1 square minus half k x2 square. So by definition, the change in elastic potential energy will be equals to negative of work done by elastic force. So mathematically, that will be equals to half k x2 square minus half k x1 square. A mass of 2 kg is lifted up from a height of 2 meter to a height of 5 meter. What is the work done by gravity and the change in potential energy due to gravity? Work done by gravity will be given by this formula. So we substitute the values and simplify it. So work done by gravity will be equals to minus 58.8 joules. By definition, change in potential energy is negative of work done, so that will be equals to plus 58.8 joule. A spring of constant k equals to 100 Newton per meter is extended from an initially relaxed position to an extension of 10 centimeters. Find the work done by the spring force and the change in the spring elastic